Good afternoon, everyone. This presentation will go through the diagnosis, key issues, and solution to the Trans-Alaska Pipeline and will be presented by Ali, Alice, Dijon, and myself.
Our aim in this assignment is to apply a complexity analysis tool to dissect the factors which make the Trans-Alaskan Pipeline a complex project. We are going to provide an overview of the project and move on to apply the selected diagnostic tools. The use of the PCAT model will provide a subjective perspective, and the W-Howe model will provide an objective perception, which allows for a complementary system and will help in conveying the results of the diagnosis to a solid point of conclusion. Then we will break down the project even further by highlighting the key issues which emerged due to the complexity of the project. After the identification process, there will be an analysis of how we would tackle the complexity in the project with justifications through various sources.
The project we have selected is the Trans-Alaska Pipeline. The project was commenced in response to the 1973 global oil crisis, which saw oil prices increase up to 400% after the Organization of Arab Petroleum Exporting Countries banned trade globally. The project led to the formation of Alaska Pipeline, a company which would oversee the design, build, maintenance, and continuous operation of the project. The pipeline's primary objective was to transport crude oil from the newly discovered oil fields in the North Slopes of Alaska to the south, near the port of Valdez, where it could then be transported by ship to the U.S. Construction of the pipeline began in 1975 and finished in 1977, making it one of the most ambitious construction projects at the time, with an estimated budget of approximately $8 billion. We have chosen to use the project categorization framework commonly known as PCAT to determine the complexity of the Trans-Alaska Pipeline project. Using PCAT, we can correctly choose the level of project management competency needed for the project. There are three categories a project can fall under, which are traditional projects, which are commonly PCAT type 5 and 4, complicated projects, which are PCAT type 3, and complex projects, which are typically PCAT type 2 and 1. Each level has their own approach of management competency needed. The factors in which the projects will be assessed are on the level of emergence, this is the measure of the innovation needed, the internal system complexity, this is the measure of the internal teams conducting the project, and the external system complexity, this is the measure of the external factors affecting the project. We as a group then went through the criteria and gave a score out of 4 on each row, which would total the amount of complexity each category would have, as you can see in the table. The level of emergence for this project scored a 10, which is classified as high due to the breadth and scale of the project. The strategies employed on this project had to proactively minimize the environmental footprint it would leave on the landscape and align with Alaska's environmental philosophy. Innovative ways of constructing and laying the pipes were created, such as the pipes being suspended where those permafrost to stop the ambient oil from melting it, along with the pipes being zigzagged to allow for buckling and expansion all throughout the year. The internal system complexity scored a 10 also, due to the scale of the project. Alyeska had over 70,000 workers to manage during the construction of the pipeline. To accommodate this, infrastructure had to first be built, such as the road alongside the pipeline. Camps would then be set up along the road, as well as radio towers to maintain communications between each camp. The external system complexity also scored a 10. In total, there were 6 stakeholders, including the owner of Alyeska. The stakeholder system was complex due to the high budget and scheduling requirements to meet demands. Through the PCAT analysis, we have determined the project is considered complex.
The W-Howe matrix is a complexity diagnostic tool, which is a 2x2 matrix that combines what and how to help us understand project complexity. There are 4 types of projects, A, B, C, and D, which are used to help identify project complexity and the effects it has on the project lifecycle. Using the W-Howe matrix, the Trans-Alaska Pipeline project is identified as a complex project as there were many elements to the project that showed uncertainty. This is considered a Type D project as it was the largest privately financed construction project in history at the time. As shown in Figure 1, Type D projects have repetitive high to low uncertainty, but the project eventually closes with low uncertainty. This was apparent in the Trans-Alaska Pipeline project as extensive tests and constant improving of engineering designs were done to overcome uncertainty. In the early stages of the project, surveyors and planners had to conduct intensive geological sampling to examine the proposed route of the pipeline. This was difficult as there was limited infrastructure in the area and crews had to be armed in case of animal danger. Alaska was also a unique location which had difficult terrain and harsh climates which
There were many key issues which emerged by the complexity of the project. The pipeline was to be built across some of the most difficult terrains in the world, which would call for emerging internal and external system complexities in this project. No pipeline in the world had ever been built that equaled the length of the one needed to cross the entirety of Alaska. One of the initial suggestions was to bury the pipeline underground, as was the standard around the world. But investigation discovered that burying the pipeline was completely unfeasible due to the climate, as the oil running through the buried pipeline would heat the permafrost around it, and the pipeline would fail, which resulted to building the pipeline above ground. During the construction process, safety concerns were booming, as the works included working in the Alaskan winter, where temperatures could reach -70 degrees below zero, and construction continued through months of perpetual dark in the winter. Due to the remoteness of the wilderness, highways were built for the construction crew just to get to their job site. However, the internal system was not the only concern, as environmentalists fear of the pipeline leading to a disastrous spill, which also led to conservationists rallying against the pipeline, that Alaska must remain an untouched wilderness. As a result of the organization of the Arab petroleum exporting countries announcing an oil embargo against the US caused the gasoline prices to skyrocket. Therefore, there was an urgent need of oil. This set the complexity of the project even higher, with a short completion expectancy of 3 years and 2 months to dig, lay, and construct the pipeline.
Due to the complexity of the issues that the TAPS project needed to address in order to be successful, careful planning and monitoring was needed to be undertaken. Firstly, the scale of the project needed to be addressed. Being a first of its kind in sheer length, it could not simply use previous case studies to find solutions. The pipeline was originally expected to run completely underground, however that quickly changed. Unfortunately, due to Alaskan climate, 420 miles of the route would be in permafrost. This caused major concern as the pipes carrying hot oil in this climate for such a long distance would create unstable footing for the pipes. To address this problem, use of above ground pipes were issued in those areas to allow for the pipe's footing to stay stable. As well, across the areas of permafrost, red pipes were used to help cool the oil so it would not further melt the footings. This was shown to be successful for the current issue, yet may cause concern later on. The embargo of the Arab Petroleum caused the project to prioritize its completion as soon as possible. Putting an emphasis on time, the project needed to be completed in 3 years and 2 months so the oil from Alaska could be traded nationally. The Alaskan climate made for extremely hard work conditions with OH&S concerns. With these harsh conditions, the need for a project to be completed fast and organized system for workers was issued to follow for the project to fit the time frame. Due to the harsh conditions of construction, the workers in harsh climate areas were issued 12 hours of work per day in 2-week shifts. With this, workers had to stay in camps and had all food provided to them until their shift expired and they could be flown across the country back home. This provided workers food and shelter as well as a set work time that they can finish, which was shown to help with the overall workload. Then there also became a problem with the demand of who would want to work in these awful conditions. Solving this was done through the wages as they were set 3 times higher than the national average for workers. This caused an influx of workers who were keen to make a lot of money quick, and this then caused high demand to the construction portion, which led to contributing to 6,000 workers who were involved in its construction. The environmental aspects included issues with wildlife, fauna, and terrain. The project attempted to mitigate the concerns in these areas as much as possible. A major concern was the impact to Alaskan fur-bearer animals as they held a modest impact to American trapping markets. Through planning and rerouting of the pipeline, the lairs and dens of these animals were shown to be very mildly disturbed and the fur bearers did not suffer greatly. Further, these minor disturbances of the pipeline are far less damaging opposed to alternative transportations of oil. The pipeline, when compared to trucks, tankers, and ships, are a far more sustainable form of transportation as they save from air pollution and carbon dioxide emission. As for the native reindeer in Alaska, concerns of migration stoppage rose when environmental groups. Yet, using algorithms, the reindeer's migration route was determined and construction of the pipeline to be lifted high enough in specific areas to allow the reindeer's passage. Through further observations, it was then stated that the pipeline is not prohibiting reindeer population in growth or migration.
In summary, using the complexity diagnostic tool PCAT and WHAL matrix, we have determined that the Trans-Alaska Pipeline is a complex project. The PCAT model provided an objective perspective that determined the project had high levels of technological emergence and internal and external system complexity. Additionally, the WHAL matrix was used in a subjective manner that identified the Trans-Alaska Pipeline project as a Type D complex project. Furthermore, the key issues emerged by complexity in the Trans-Alaska Pipeline project were dealt with in innovative ways, where the design of the pipeline was constantly improving to cater to stakeholders and the environment.
That concludes our presentation. Are there any questions?